In this video, we're going to take real-world situations and we're going to create and write our own exponential equations using the basic parent function of an exponential equation, ab raised to the x power. So a couple things before we get started. We have exponential growth and decay is based off these two equations right here. So we have f of x is equal to your initial value times 1 plus your rate raised to the x power. This is for growth. And decay would be f of x is equal to a, your initial value, 1 minus your rate, raised to the x power. Here we're dealing with percentages, so make sure that you change your percentage to decimals and subtract and add accordingly. So there's our notes for that. And here's the first question I want to do. It says, imagine a video game where a player's health starts at 100% and decreases by 5% of its current health with each hit the player takes from the boss. Create an exponential equation to represent this situation. Is the player still alive after 17 hits? So we have to find out what our initial health is, and our initial health right here is 100%. So with our equation, I'm going to say the function of x is equal to your initial percentage, which for us is 100%. And we need to see how much a hit takes place, or how much does a hit take on the player, which is 5%. So I'm going to say 1 minus 0.05. So 1 minus 0.05, because we never use the parenthesis, we only use the decimal for equations, raised to the x. So that's going to give me 100 times 0.95 raised to the x. 0.95 is less than 1, which means that this is going to be a decay graph. So here is the graph. Here's the equation for the situation. 100 times 0.95 raised to the x. The next thing we need to do is see if the player is still alive after 17 hits. So to do that, you need to go to the graph, and you need to plug in 17 for your x value. And let's see if he's still alive after those 17 hits. So we go to our calculator, we look at our first graph. That's what it looks like, starting at 100, and it slowly decreases all the way down. And after 40 hits, he's still alive. So we're going to see what his percentage of health is after 17 hits. So to do that, you hit menu 5-1 to trace the graph, and you type in 17. And it gives me 41.8% health. So f of 17 is equal to 41.8%. And that takes care of question 1. We go to the next question. And it says, suppose a smartphone company currently charges $500 for the newest smartphone. That's our initial value. So we have question 2. F of x is equal to 500 times 1 plus. So we look at it, inflation causes the price of the newest model to increase by 3% each year. So 1 plus 0.03 raised to the x. So when I take care of my parentheses, I have f of x is equal to 500 times 1.03. That's greater than 1, so that means it has to be a growth. So what we want to do is look at, here's our equation. After the situation's been given to you, your initial, and then 1 plus the percentage rate of growth, and then it says, what is the price after 13 years, and is it a reasonable price? So that means for our x value, we need to plug in 13 and see what we get. So here I've got f of 13 is equal to 500 times 1.03. And we change the x value to 13, and we see what that value gives us. That's where we can use our calculator to help us with it. So here's the second graph. We see we start at 500, and we're slowly increasing as time goes on. Each x movement, 1 unit, means 1 year. So We're going to go ahead and look at this and hit menu 5.1. And we want to see what happens after 13 years. And we're at $734. So the question is, based on this timeline, after 13 years, let's say that we started, in 2000, and the price was $500 for the newest iPhone. And then as time went on, after 13 years, it increased to $734. I think this model represents it accurately. And, after you get out to 50 years, maybe it's going to get a little ridiculous because it keeps increasing. But right now, this model matches the data that comes with what we're given. So again, here's the work that we did. Question 1 was a decay graph because it was less than 1. Question 2 was a growth graph because it was greater than 1, the rate or the base of your exponent. And then there's our answers. 41.8% for question 1 after 17 hits. And after 13 years for the cell phone, you're up to $734. That's how you write exponential equations given information with a real world situation.